insert it, and they just start running the SQL queries and they report the slowness. So we have to make sure after insert or heavy data load, the stats are gathered so that the subsequent SQLs may perform better. And then temp table stats is used. So some application team uses the temp table to kind of lookup table, and you may there may be a situation where we have to insert only one row, and we'll just look for that one row to run some reports. Because of that one temporary table which has only one rows or two rows, there may be a slowness observed on the SQL queries. So what we can do is, for temporary table, what we have done based on my experiences, for temporary table, insert the records, and then because there's no possible to gather stats on temporary table, because it's actually the common the one table can be referred by different sessions, so data are not persistent, it's different. So insert the record, lock the statistics. Once you lock the statistics, which means stats are set for one record, so Oracle knows that it has only one record, so that will give the right performance to the other dependent queries. And then the comes to dynamic sampling is we have dynamic sampling starting from 1 to 12. So if there is any stale statistics, Oracle will use the dynamic sampling to get into the right accurate number of rows, which is nothing but cardinality. We'll see in detail in the over the course of time. And lookup tables. So instead of temp tables, some application team uses the lookup tables where they insert a record, and if you insert one record, you may be seeing some hot blocks, because there may be more than 10 plus sessions, 100 sessions referring the same blocks. So you may see some kind of concurrency. So what we can do is, there is option starting Oracle 10, I believe, where we can insert a record and minimize the rows per block. So once you minimize the rows per block, that table will have few number of rows that you have to insert it, and you have to alter the table with rows per block. So one block will have only one or two rows, so there will be no chance of getting into concurrency issues, particularly if the lookup tables are really heavy, where you see the concurrency issues in the OEM or in the wait event. Subsequently, when it comes, then ASM is nothing but automatic storage management to balance the IO. If the storage are from the different IO groups, if they may have some different set of IO groups, 10 or 20, and if we get the storage from the different applications, different IO groups, we can configure ESM to get the IO bottleneck. Because if the database says say 5 terabyte, and if the storage team ideally would give 5 terabyte of storage from different IO groups, but that will be mounted as a single mount point, there will be an issues. So what we can do is, we can configure ESM to balance the IO to avoid hitting the IO bottleneck. Then PGA for data warehouses. This is nothing but like SEA, we can configure PGA for data warehouses to increase the sort area size. Right now it is limited to 2 GB. That is, one session cannot go beyond 2 GB. And we have an option to set the hidden parameter where the size can be increased up to 8 GB, I guess. So for data warehouse specifically, where there are terabyte of data involved, really this would help. And Oracle upgrade execution plan. So when you want to upgrade database from 9 into 10 to 11 or 11 to 12, most DBS or application teams are worried about will there be any performance issues. What we can do is, we can take advantage of our baseline, capture the baseline, uh, capture the baseline when 11, assume you're going from 11 to 12, 11G to 12C. Capture the baseline for all the sequels, and then once it move to 12C, use the baseline, so there won't be any plan change. Then over the period of time, you can gather stats for 12C. You can delete all the baselines to make sure there's no performance issues comes just because of upgrade path. Make use of ASH and ADDM, that is active session history and ADDM report, which will generally give the better recommendations if there is any basic issues are there. And get the real stats. Real stats is nothing but, don't assume something is if something is really going bad, don't assume it. Look into actual stats, get the analysis done, and recommend that to application team, or fix it yourself by the optimizers, parameters, or other tunings. Then network tuning comes to, there are some very rare cases which I faced in my environment. Some application server needs certain SQLnet dot order parameters to be set, that is to receive, because when they run the applications, mm, the data will be the round trip, that is from database to application server, the round trip data will be very high. So instead of so to avoid the round trip, we can increase, we can set certain SQLnet dot order parameters to avoid the round trip options. We'll be discussing in detail later. This is what I was discussing. That is baseline profiling, which we already discussed it. Check and read the actual execution plan, and if because when we see the issues, the at the end we'll be seeing some problematic SQL behaving something badly. When we look into detail, we'll come to know whether that is because of plan change. 80% of the case, the SQL would behave badly because of plan change, which is nothing but because of stale statistics or some other issues. The plan change may occur at any time. So to avoid the issues, we can baseline it. If you know the right hash value, you can still baseline it using the baseline options. That is, create plan baseline in the databases, set the hash value, so there won't be any plan change happens for specific SQL. That is fixing it. You take advantage of SQL tuning advisors, repair, and then manual SQL profiling, which is nothing but this is something different than the what the manual the different than the SQL profiling. Manual SQL profile is nothing but we can without modifying the query. If you know the problem, the query is behaving badly, and if you want to and you test it with certain hints, and some application team doesn't know or don't want to do any code change, like if you want to put parallelism, or if you want to tell the optimizer to use different indexes, some application team may not agree to do code change, because though to hint it you must do some code change at the application level. So what you can do is you can use take advantage of manual SQL profile without doing code change, without touching the actual SQL. We can tell the optimizer to change their behavior using manual SQL profile. This is something interesting. We'll go in detail when we talk about it later. So these are the general recommendations which we already discussed. Load profiling, top weight events, DB block changes, segments, logical and physical reads, the top resource SQL, and comparison of AWR report. This is, see, some you can when the report issue, if you don't see any issue in the databases, you can compare the reports always. You can take advantage of comparison reports. Go here, AWR and check the compare period reports. See, this will give you both the snapshot, first period and second period. You can see, assume today we had an issue from 8 to 9. You can similarly you can go back to the last week at the same time, get the two snapshots and today's snapshot to check if there's really any issues. There may be a change from the application side, which you may see some higher number of executions for specific query. You can always report to say application team. Sudden slowness could be due to the plan change. If there is no plan change, you can always be ready to compare the reports between the ELA time and the current time to check if there is any bottleneck. To going into the details of physical rates, top resource SQL, you will be able to see any SQLs are running abnormal number of executions, or behaving something bad with respect to the physical rates or logical rates. It could be anything. So we just need to go properly each and every line on the comparison report, starting from the SQL part, and will really give some clue to get into the issue on rightly. Look for lock on latch contentions. Obviously, you'll be able to see from hash report as well as from the OEM report these things. Fragmented segments. We may not see there is a plan change for sequels. Once you get into the sequels, it's not always you should be able to see there is a plan change, but for some reason it's slow. Some application team may say yesterday it was okay, but today it's running really bad, and immediately you can check whether the underlying segments, the table or indexes are fragmented. How do we check? Take advantage of segment advisor. Go here and advisor home. You can see the segment advisor here, segment advisor, and look at the, if you know the right index segments, you can always explore the options to set the segment advisor to check if there is any really fragmentations. For example, if you want, oh, I hope you have time. What is time now? Can we extend up to 9:10 for another 15 minutes? Uh, just want to finish the leftover slides. I hope everyone is okay to spend additional 10 minutes to check it. Say this is the one of the temporary table. So I'll just take this SQL, getting into the table name. See, this is one of the table name, I guess. Copy it, go to performance, advisor home, create